You see here in object-oriented programming, we have this keyword here, object. So first, let me go back and explain when you did programming in 151. Your program, if you recall, was made up of what? When you wrote your program, you were writing it into smaller pieces, functions. Okay, so your program, especially in a complex program, you cannot imagine a complex program in one function. What's the problem if we write all our program in one function? What will be the issue? Sorry? Yes, it will be difficult to read, difficult to understand, difficult to develop in the first place. And it will be very complex. Whoever opens it, they will just run away. They will never come back again because it's just too much to handle. So imagine something like PowerPoint or Word as a program written in one function. Is just not feasible. So that's why we really need, whenever we have something complex, we break this complex thing into pieces. And there are many ways of breaking things into pieces. One way that you have already seen in CMPS 151 is that you broke your program into functions. So your program becomes a set of functions, function 1 to function n. And one of the lucky ones will be main, and the program will start running from there, and then the program will, one function will call it, the functions will be calling each other to achieve the functionality that the program is intending to deliver. So this is one way. This is one way of breaking your program into, one way of decomposing your program is to break it into functions. Yeah? And this the concept of decomposition of a solution into pieces is a fundamental concept. In any engineered product around us, you will find the product or the item made up of many components. So for example, even the table, you can see, for example, this table here is made up of many pieces. And then the manufacturer of this table assembled these pieces and put them together to produce the table. And maybe the pieces are made up by different companies, or maybe even made up in different countries. And maybe the table manufacturer buys these components and put them together. Same thing for even for this mouse is not one piece. It's components, and these components are put together. The computer itself is a component, and these components are integrated to produce this computing device. And these components could be produced by different people at different times in different locations, and then we bring them together and assemble them to produce this product. So the concept of decomposing a product into elements and then putting these elements together to produce a product is very, very, very common in our daily life. We see it all around us. Yeah? And there is no exception. Software is a piece of product, and then when we produce it, we break it into, one way to do it, we break it into function. But another way to do it, especially in this course, what do you think, based on the title of the course? We break the program into objects. Yes? So at the end of this course, you will learn how to make programs that are made up of objects. So your program will have object 1, object 2, object n. Yeah? So now let us try to understand what this concept of object means. All right. So the story goes like this. You know, the things that are around us, let's say in this room, what are the things we find in this room? Tables, chairs, computer, data show, yes, projector, lights, speaker, window, the room itself. Yeah? So what is the general term we can use to kind of describe all of this? What is the general term for all of these things that we just listed? Are objects, are basically ashya, that are around us. Yes. So when we write a program, usually when we write a program, we are writing this program to solve certain problem in a real world. Okay, and the real world is made up of objects. So our program should be a reflection of the real world, and our program should be made up of objects. That is basically one of the ideas. So because here, this decomposition of a program into functions, it's not really very natural, because I never met any functions on the street. I never seen any function walking on the street, or I greet any function. But in contrary, I have seen around me what I see, objects. So it is much easier to inspire and take objects from real world and represent them in our program, rather than trying to represent the real world in our program as functions. So that is basically the kind of the philosophical idea of object-oriented programming, is that you take objects from real world and you represent them in your program. And your program becomes a set of objects that are interacting to achieve the functionality of the program. Okay? So let us start with some concrete example of what an object really is and how we describe an object. Let me take an example of this object that we see, the lights. Yeah, the lights here. So when we describe these lights, what do you think? What are the things we can use to describe it?
It's square.
Let's say not the light, not the. I mean the bulb, the lamps. I mean the lamps. Let's describe the lamps. You know, the ones that we switch on and off. Sorry?
Lamp.
Very good, yes. So first of all, maybe, as you mentioned first, maybe the shape of the bulb, of the lamp. It could be maybe either, it's kind of either it's a bulb, or it's a tube. Yes. Yeah. So these are, you can see there, they are tubes, and these ones, can think of them as bulbs. Yeah. So the shape, it could be either a tube or bulb. Okay. What else we can use to describe the?
Maybe glass.
Okay, maybe the material it is made up of. Not volts. Maybe let's ignore this one. The watts. Yeah, number of watts. You know, when you go and buy the bulb, you can see 40 watts, 60, 90. Yes?
And the color.
The color, thank you very much, the color. So for example, let's describe this one. For example, this bulb here is a tube bulb, and the watt, I'm just guessing, like let's say 60 watt, for example. And then the color, what do you think the color? White. Yes, in this case, most likely it's white. We will turn it on and see. White. What else we can use to describe?
So, lifespan?
You mean the light intensity, maybe? Yeah. Light intensity. What else? When you buy this bulb, number of users. It will be very difficult. I mean, the manufacturer will claim you can use it.
How can we turn it on? Because some of them, like when we clap it's on, some of them will.
Okay. The state, whether it's on or off. I mean the state. What is the state of this lamp now? Off. So this is off. Another one is basically the brand. You know the brand?
Yes.
It could be Philips, it could be GE, it could be maybe LG or whatever. Okay? Maybe we just put here Philips. You see what I mean here? So what I'm trying to do here, I'm trying to describe or to capture some of the properties and some data about this lamp, this particular lamp. Yeah. So this is basically a lamp. as an object, I'm describing it using these properties. Yeah? Now, if I take a table, I want to describe this table and represent this table as an object in my program, what are the properties or what are the data that I can capture about this table? What do you think? The size? Size, maybe I can take the length, maybe 70 centimeters, maybe. The width, maybe 40 centimeters. The color, the height, the shape, rectangle. The material, it's wood, and maybe this is metal. The color, white. The weight, thank you, this is maybe 10 kilos. Sorry? The brand. The size then. What else? Maybe, you know, some of the items, they have an identifier. Have you seen some stickers on some of the assets at the university? Some stickers. Have you seen some here? Maybe the tables they don't put, but the desks I have seen in some rooms. Oh, thank you very much. You see here, this is an object. Yes, thank you. This is a good example. This object is really an object represented as one of the software of QU. You will find this object represented in their software. So you will find speaker, and you will find that sticker there, the ID. You can type it in that software, and it gives you information about this speaker. It will tell you this is a kind of brownish white speaker. The brand is Parts. I can see here the brand. I can put the location. Where is the location of this speaker? C07144. Yes? You can see those are properties. So this is a good example. Every object, by the way, in this room might be tracked by some software. We know in maybe the BOD, I think they call themselves business operation development, something like this. This building, there is some people sitting there. They manage the assets at the university. And these assets, when they need to describe them, and they need to capture them in their program. So in the program, there is an object called table, and table has these properties. There's an object called let's say speaker, and it has these properties, and so on. Okay, so this way they can track where the assets are, when they purchase them, when the maintenance is due, when the replacement is due, so they can replace it with something else. So what I mean here, there are objects in the real world, and these objects can be represented in our program. Is clear what I want to say here? Okay, so when I represent an object, what are these? Features, or the proper name is basically, these are attributes. We call them attributes. What do we mean by attributes?
Like description.
Yeah, like data items, or like some pieces of information that describe that object. Some pieces of information that we care about in the object, about the object. Yes? So let's take another example. Let's take another example just to make sure we understand the concepts of an object and the concept of attributes of an object. Yeah? So now, if we take most of us, or all of us, we came here using some car or some kind of vehicle. Yeah. So maybe I'll describe the vehicle I used to come here, for example. So what could be the attributes of a car? What could be the attributes?
The brand.
The brand, thank you. So maybe the make, we call it the make. In my case, it was Toyota.
The size.
Sorry? The size, or maybe let's say the type. The type is like basically is a family car, for example. The speed, the speed, yes, could be, but
not from
the engine size, yeah, not from the outside. I mean, we want something simple, like some attribute that we can see on a particular object. So the engine size, let's say the engine size is 2 liters, for example. The color, okay, color. It's gray. The year of manufacturing, like 2016, for example. What else? Plate number. Thank you very much. This is very important because it is an identifier, very critical. Plate number. It's very challenging question. TAB 1, 2, 3. I don't know the plates. What else could be? These are more complicated. I just want to keep it simple. But in the real world, what that will be, it will be because tires, to represent it it's more complicated. Let's leave that one. Because an object could be made up of other objects. Because a car is made up of an engine object. And then we need to describe what the engine object is. And it's the car is made up of multiple tires. It will be an array of tires, and we need to describe those tires. But for now, we just want to keep it simple. Just focus on simple attributes. Yes? Sorry?
Number of seats.
The number of seats. Thank you. This is a good one. Number of seats. Very good. So this is 5 seats. 5. Okay, I described mine. Somebody can describe a car that they know of. What do you think? Give me some description and make. Nissan. Okay, thank you. All right. Now the type. Sports. Very good. We have some sports drivers. Engine size. Because it is sport. 4 liter. Let's say, okay. The color? Yellow. And the year? Brand new, of course. 2019. And the plate? Of course, very distinctive plate, number 111. And then the number of seats? 2. Very good, because it's sports. 2. You get the idea. So in here, I can describe as many objects as I wish by capturing those attributes and giving them some values. Yes? And these objects will be managed and manipulated in my program. Is clear so far? Now, when I want to really sit down and write the program to capture this information, yeah. Now, I might have hundreds of cars. So I'm not going to sit and program each one by itself and repeat this definition again and again and again. So although I have here objects, I have here many objects, what I do, I create a definition for this object. Okay? So what I mean here, let me create another one here. The definition could be something like this. A car, if I want to describe a car, it has some attributes. One of the attributes is the make. What is the data type of the make? It's a string. What about the type? Family or sport is a string. What about the engine size? It's an integer. What about the color? It's also a string. What about the plate number? Plate number is also a string because usually it has letters and numbers. Or if we are only describing cars in, let's say, in Qatar, maybe it's only numbers, let's say. Okay, but let's keep it generic. What about the number of seats? Number of seats. It's an integer.
The year also is integer.
The year. Yes, thank you. Okay, let's put it here. the year, the data type of year is an integer. Okay, so before I create this object, I first create one definition of this object. What we call this definition in the object-oriented programming terminology? No, declare is basically I create, when I say declare, I'm creating a variable. No? In here, I'm creating a definition of an object. Yes, please. It's a class. Thank you very much. Don't worry about, this is an introduction. So I want you to grasp try to understand this as much as you can, that we will revisit this again and again until it becomes super clear. Because this is the foundation of what this object-oriented programming is all about. So this is a class. We call this a class. What is a class?
Definition.
Is the definition of an object.
The attributes of an object.
The class has define the attributes of the object. Yes? Define. So class has attributes. Very good. What about the object? What is the relationship between an object and a class?
The object is a part of a class.
Is the object part of a class? Is a class part of the object?
Class is the object.
Class is the object?
Object is a
Part of a class?
The class is the object?
No, not really. What we see here, what is this? This is an example object. This one, what is this? Another example. So basically,
And the class has many objects.
no, a class is a definition. Using that class, you can create as many objects as you wish. Okay? Think of it as if it is a design, some kind of design. We all of us walked into some compounds in Doha. You can see when you walk into a compound, what you see, houses or villas, or typically, how these villas look like? They look exactly the same. Okay. So what's happened is this architect, they created a definition of one villa. I'm 100% sure they didn't design each one separately. They created one design, one definition, and they give it to that builder, and they start creating as many copies as they wish. In some 30 villas, exactly the same. How many definitions, how many designs, how many blueprints? One. Yeah. Now this builder, because there is the architect, there is the builder. Yes. Now this architect, when they hand over the design to the builder to build, how many designs, how many definitions they give? One. And then this builder, what they did? Repeat and create many examples or many instances or many objects from the design. So in this analogy, which one is the class, which one is the object? Design is the class. And the objects are the houses built based on imagination of the builder? Based on the definition defined in the blueprint provided by architect. You see the idea?
The object is like something from the class.
Yes, created based on the class. It's an example. It's an instance. It's an example of the class. A walking example. Can you see the design, something concrete? Can you go and touch the outcome of the design? No, it is just a definition. So for you to have, can you go and live in that blueprint that the architect has spent time defining? No, it's just a definition. So for you to have some place to enjoy and live in, what do you need to do? Go and create an object based on that definition. Is clear? Now the Toyota people, do you think the constructor, they just sit down, drain the car, and then they go and start assembling the parts and here you are a car? What they will do?
They They think about the speed, about the size, about the material that they use it.
Okay.
This car.
And they capture this in all what? They capture all this detail in a design. There's a blueprint of the car. Of course, it's top secret. Okay? They are the dimensions. What's the size of each piece? What is how the pieces are fit together, and so on. Lots of details are there.
First, they make one to try it.
Yes. So first of all, they have the design, and they might even test that design in some simulation, and so on. Once they are happy with it, then they will create a prototype, and they can use the prototype to further refine the design. And once everything is refined, then they can send it to China or India or somewhere in the world, and then produce as many cars as they wish based on the design. If you don't have the design, can you create a car? You can create a car, it won't move, it will crash, it won't be a car. You get what I mean? Yeah? So we always have this concept of definition or design or blueprint, and then we have things, objects that we create based on that definition. Exactly the same. Are you following? So what I mean here, we have objects in the real world, yes? We represent this object in our programs. Now, when we represent this object as developers, what do we need to create first? Class. And then based on the class, I create as many objects as I wish. Is the concept clear? Okay. Now, a class, what does a class have? When I define a class, what is the first thing the class has? The attributes. Is clear? What are the attributes?
The properties that describe the object.
Thank you very much. Properties that we care about that describe that particular object. Yeah? Now, do objects only have attributes? If objects only have attributes, believe me, most of them will be useless. What do you think objects also have? Purposes, thank you very much. They deliver some functions. They deliver some functionality. Otherwise, they will be useless. Yes? So, this lamp, for example, what we can do with it? What functions it can do?
Light up the room.
Light up the room, thank you very much. So, we can turn it on, give some light, and then when we want to have some rest, that light becomes annoying, what we will do? Turn it off. You can see here, we described the bulb. Didn't we describe the bulb? What did we say about the bulb in terms of attributes? It has a shape. It is a tube or a bulb. It has a number of what? It has a color. It has a state. Now, what is the state of the bulb? Off. Okay. What else it has? The brand. If you come closer, you will see little brand written there. Philips or some other brand. These are attributes. Now, objects not only have attributes, what else they have? Functionalities associated with them. What are the functionalities associated with the bulb? What is the functionality this one can do? On and off, that's it. Because this is very basic one. It's not a smart one. Yeah? You get the idea. So, to summarize, an object has two things: attributes and functions. Attributes and associated functions. Now, functions, when we put them in class, we don't call them functions. What do we call them? Methods. Don't let these terms confuse you. It's just terminology that you need to be familiar with. So, an object has two parts: attributes and methods. Of course, same thing. When I create a class will have what? Attributes and methods. Attributes and methods. Now, for a car, what do you think the methods will be? What will be the functions of a car?
To drive.
To drive, yes. but a little bit more precise. What function, exact functions you can ask the car to do. In here, what I could ask the lamp to do? Turn on, turn off. That's it. 2 functions. Don't tell me any other function. That's it. That's all it can do. Maybe if you have smart lights at home, maybe it can do some more things. Change the color, maybe change the brightness. You can. But this one, the poor man's one, only does 2 things. What about the car? Thank you very much. That's it. It can do move forward, move backward, and hopefully stop. In high level, these are the 3 major functions. You cannot do more than this. Even turning, or these are still moving forward, moving backward, and stopping. Those are the basic functions of the car. It's clear? You can basically ask it to move forward, move backward, or stop. Yeah. Of course, you can, when moving forward, you can move forward with different speed. You can control the speed. Yeah. You can basically accelerate while moving forward, or accelerate while moving backward, and hopefully it has some stop. So when you see some stop sign or red light, you stop. Anything else it can do? Can it fly? Jump? No, that's it. Okay. Now, of course, you can do other things, but those things are not really functionality of the car. The functionality of some parts of the car. For example, AC. Now we're not talking now about the car. We're talking about AC of the car. Of course, AC you can do again on, off, and change the level of the temperature, either to cold or hot. Yeah. But only on and off. That's all you can do. Switch on, switch off, and change the temperature. Yes. Now the lights in the car. It's not the car. You are talking now about the lights. Again, you can turn on, off, and maybe intensity. Is it just the normal light or the far light or the high beam light? You get the idea. Yeah. So that's how we capture objects in the real world and represent them in our programs. We discover them. We don't go and dream about objects. From where we get these objects? From the problem we're trying to solve. Yes? From the problem we're trying to solve. So now, let's summarize. See what are you, if you are still with me or I lost you. Okay, so at the end of the day, if I look at a running program, if program is running, if I look at it, there's a running program here, and I happen to have some glass window here, and I see the program running. And this program was written in an object-oriented programming fashion. The style that was used is an object-oriented programming. What I will see inside this program?
Classes and objects.
No, I will not see classes. In the running program, I will see objects. But in the program itself, the source, the program code, I will see classes. So a class is a definition. So for me to do anything useful with the object, with the class, what I need to do? Create an object from it. Yes? So to summarize, in an object-oriented programming world, a program is made up of objects. Us as programmers, when we want to develop these objects, when we want to create, before we can create an object, what do? We create a class. Okay? We create a class. And a class has 2 things, is made up of 2 things. Attributes. What are attributes? Properties or data elements that describe the object. And what else the class has? Methods. What are methods? Functions that the objects can do for us. Functions that this object can do for us. And sometimes these methods, they change the attributes of the object. For example, remember here in our lamp, when I call the switch on method, what will happen to the attributes? Which attributes will change? The state will be on. Some attribute will not change. The brand will not change. Okay, but the state will change. You get the idea. So some of the functions, for them to do their work, they might use some attributes or they might change the value of some attributes. Okay. Now, when we create this class, what do we do with these classes once they are created?
Add object.
We can create as many objects as we wish from this class. Object 1, object 2, object n. As many objects as we wish. Because a class is a definition. And based on that class, I can create an object. Is the idea clear?
Yes.
Okay, good. Now, since we jumped here, let me just jump and try, if I can, give you a concrete example, hopefully, in programming, how it looks. Okay, let me see. Come on. So what I will do, I will go ahead and create a class. Let's create a class together that will capture this. Yeah, and then based on that class, we will create what? Some objects. Yeah, let's give it a try. Thursday, everything is slow, including banner, Eclipse, everything. Okay, so it is coming. So this is, of course, the introduction. We will see as we move forward, when you have a problem, how you identify classes. How do you identify properties, attributes of these classes? How do you identify methods? How you program them? How you make these objects interact with each other? And so on. Also, objects could have other objects, could be made up of other objects. Remember the car? We're made up of an engine, or we're made up of a tire, like let's say wheels. And those objects have their own attributes and their own functions. And let's create an example class. Okay, new, can you see here? In Java, can you see something there? What I'm going to create? A class. So in object-oriented programming, as programmers, what do we create? Classes. Okay? Class. Now, which class I will be creating? A lamp or a bulb. Let's call it a lamp. Is it with AMP? Yes? Yeah, okay. Now, this name, you can see here, this name is derived from the real world. And this is the power of object-oriented programming. It is a reflection of the real world. The gap between the software and the real world is narrow. Yeah? It's not like before, when people before us in the 60s and the 70s, they used to program using maybe machine language or assembly. The gap between the real world and the program is so far, but now things have been developed. The gap between the way we program and the concept we embed in our software and the real world the gap is narrowing. Yeah. So do we have lamps in the real world?
Yes.
Of course we have. Yeah, they are on top of us. So many. We will have now a lamp in our software. You got the idea. This is the power of object-oriented programming. The objects that we manipulate and the object that we will program in our program or in our software, do we dream about them, have a nap, and then see them in our dreams and then wake up and write them? No, where do we get them from? The real world. Depending on the application we're trying to build. For example, let's say here, I'm trying to build an application to track these lights. Every light that is installed in QU, I want to track it. I want to see what is their brand, what is their color, the number of watts, when did we install it. And then when I will come back to it to check if it's still working, or when do I come back and fix it. So I want to write a program to do this, for example. So first, I need to have some kind of class that describes the light, and then I create as many instances. Anytime I install a new lamp, I go ahead and create a new object, so I can track it later on. You got the idea? Yeah? Okay, so that's it. We create a class, It's called a lamp. Finish. What do we have at our hand? A class. So how do we create a class in Java?
New class.
Public class and the name of the class. Can you see the name there? The first letter is uppercase. Please always make your classes first letter uppercase. Otherwise, other Java developers or other developers will think this is a new baby developer, they don't know what they're doing, because you will reveal that you are still beginner if you don't follow the naming convention. Yeah? A class, is it a noun or a verb? Noun. So what do we learn now? What do we learn from this? A class name is a noun. Please don't never put a class name as a verb. And a class name starts with uppercase. That's it. Is this clear? This is a must. Must do this. Okay. Now, let's move on. And then what I will do here, I start defining what? The attributes. Very good. What were the attributes we came up with? Okay, thank you. Good. Shape. Okay, let's go for it. So what did we say? String, shape. Color, string. What did you notice here? The attributes. How did I write them? Data type. Then the name of the attribute. Yes? Is the attribute a noun or a verb? Noun. Color. Is it a color verb? Shape. Is it a verb? It's a noun. What do you think the first letter of the attribute? A lowercase. Keep this in mind, yes? From day one, I'm telling you. The class name is what? Is it a verb or a noun? A verb, a noun. The class name is a noun. The first letter, uppercase. And the attribute names, nouns, and the first letter, lowercase. Is clear? Camel casing, if you have, this is a little bit more advanced, if you have a compound word, a word made up of multiple words, yeah, then what you do is the first letter of every word, you make it uppercase. For example, this is a lamp. For example, this is like a tube lamp. I can create tube lamp. So T of the first word is uppercase, and the L of the second letter is uppercase. Yes? Okay, I'll have to be quick now. What else? What other attributes? The color, what was? The brand. Yes, the brand is also a string. I need to be quick. Okay, here is a string. And then what else? Number. You see here number of what? Can you see? This is called, the way I name it is very important to name. Nobody, the Java program doesn't care, but other developers do care. You have to follow the naming convention. What is the type of this guy? Integer. So let us keep it simple for now. Yes? Now, in terms of functions, so what I will do here, public void, I will explain this later. Turn on. Okay? What this function does, we forgot something very important here. State. And by default, the state is, let's say, off. What this turn on does, all it does, it will change this state to on. Let's make it, or let me put it a much better way. Is on, by default is false. And here, when somebody turns it on, then is on becomes true.
Doctor,
Yep.
why don't you do the Boolean?
Yes, you're right. Thank you. You get the idea. This is a function. The other function is What's the other function? Turn off. And what this function will do?